Hi, I'm Galafridis Peregrinus, and this video is of my current project, one that I've been working on for the past few years, of making a quernstone. The quernstone is way pre-period. It's proto-Neolithic, let's put it that way. So what I've been working on, this is in conjunction to the stuff that I've been doing in connection with wheat, is I've been trying to figure out how to make a flat quernstone, a flat grinding stone for processing grain in the way in which it was done long ago. The first ways in which grain was processed to make porridges or gruels or things of that nature. What I'm working with is a slab of quartzite and another stone that I'm using to shape it. The material is based on quernstones that I've seen from the collections of the Smithsonian that were found in a cave in northeastern Iraq. Those quernstones were made out of a quartzite type of stone, a very hard metamorphosed sandstone. This particular quartzite came from up the Hudson Valley, from the Taconic Ridge, actually the Berkshires, and it is a very hard Taconic quartzite, which is appropriate for millstones. I've had conversations with people who are involved with historic milling projects and also with other experimental archaeologists, and they've explained that the way in which these flat stones were formed in the absence of steel or metal tools was by a process known as pecking, which would involve taking a smaller stone and just dropping it like that on the slab, and you just repeatedly drop it, keep dropping it like that. You do not pound with it. That takes too much energy. This is a very slow process. The last time I spent some time working on this, I spent about 40 some odd minutes. I would guess I removed perhaps half a teaspoon of material. Quartzite is a very hard stone, like I mentioned. It's also brittle. So my experience of using this stone as my pecking stone, because that's what this process is called, this process is called pecking, as you can imagine. But the last time I did this and this, there we go, it broke. Because it's quartzite, it's brittle. So again, the process. Now, one person suggested that it can be sped up by, you see, I'm giving it a twist as I'm dropping it. The idea being that that would create a little bit more abrasion, a little bit slightly different stresses. The other piece of advice that I had is to leave the dust, to leave the grittiness in place, because apparently that helps the process along. But as you do this, this piece chips. So not only does the surface get smoothed out a bit, but this begins to break up. So you do well to have some backup pecking stones. So for example, here we go, I have another pecking stone ready to use when these things get used up. So again, the idea of this project is to make the stone on which the grain was milled, and then to mill some grain for foods like gruels or bulgur or couscous or whatever type of food. grain-based food. I am not working on grinding to flour in any way in which it would be used for making bread. I'd want a somewhat more advanced technology, shall we say, maybe a rotary quernstone or something like that, if that's what I was interested in. I'm not really all that involved with the bread, with the making of bread and such. In any case, it's a little bit more my wife's project, the type of project than mine. But the idea is that eventually I will have some kind of stone that I can use to do some very early wheat and grain-based foods, making them using the stone. One of the other things to keep in mind is that very likely the stone was formed as much by the use of it as it was by the preliminary pecking. So one would take a handstone, and we'll use my pecking stone as a handstone to demonstrate this, is you'd have the grain sitting on the flat slab, and you take the handstone and you would just hold it and grind the grain. Now, what you would probably do is take this smaller slab and put it on a larger flat stone, and then as you were grinding, the grain would fall off the sides, you'd sweep it up, put it into a basket or a bin, and then use it for whatever food that you were cooking. That's a very common way of doing things. Even with the rotary quernstones, the rotary quernstones were often put in a box, and as you were grinding, the grain would fall off the edges. You'd collect the grain, the processed grain, and use it for whatever purpose you had in mind. Okay, I just dusted off. I wasn't supposed to do that. When you're doing this, a couple pieces of advice. You do want to be wearing gloves. Either that, or you better have some nice horny calluses on your hands. But you do want to protect your hands. And if you're going to be doing it for any length of time, I suggest wearing a mask. Now, I realize masks are in short supply these days, but maybe a bandana wrapped around your face or something, so that you're not breathing in rock dust. Rock dust is not healthy for human beings. One final comment about the sorts of materials that early millstones were made out of. You can find a lot of information about the different kinds of stone, a lot of suggestions. Some were made out of a basalt, very, very hard igneous rock. Some were made out of the hard sandstone, or like the quartzite, which is a metamorphosed sandstone. Some were made out of limestone. So there's a whole variety of materials that they were made out of. Some were made out of softer sandstone. The peoples that ate grain-based foods that were ground on the softer stones, they did not live as long. Why? Because they were eating grit, and the grit was doing not good things to their insides. Also, it was grinding down their teeth. My understanding is that the Egyptians did not live as long as they might have because they had their millstones weren't good quality. The Egyptians made extensive use of wheat, bread, and they used it for beer and a whole bunch of other things as well. But they did not have good quality millstones. They used a softer stone, and they ended up with gritty bread and gritty cereals, and it shortened their lives. So that is the process. Again, you see. And as you're doing it, you can see that a dust sort of forms. And again, the ideal is to leave that dust in place because it helps the abrasive process. So I hope this has been an enjoyable thing to watch. Feel free to comment or post questions to me, and I'll do my best to answer. I hope everybody else has some interesting projects going as well.